Hi, my name is Tasin Towsif Rahman, and today I'll be discussing about the tasks that I have completed from our ITEC610 Assessment 3. So for the first task and the second task, we were given a dataset from the BRFSS, which is the Behavioral Risk Factor Surveillance System. It is a premium system of telephone surveys regarding health-related concerns collected on US citizens. So from that data set, we can see that a sample over here that I have provided, it contains 6 prime columns, which is the age, the current weight, the weight a year ago, the current weight in 2 decimal points, and the height along with the gender. The height is in centimeters and the genders, number 1 represents a male and number 2 represents a female. So before we go into doing any assessments, we start by loading the dataset into our Colab environment using the pandas library, which is for dealing with datasets in the notebook environment, which it's a useful Python library. And the matplotlib library is used for visualizations, and NumPy is used for dealing with arrays and stuff that we have from our dataset. So we first load the uh, dataset that we have, which is in the form of a CSV file, into a data frame over here, which is whose variable name is brfss underscore df, and the view of the dataset that we have in our notebook is somewhat like this. We can see that the columns in our dataset contain a lot of null values, and since we have an abundant amount of data records available, the decision that I have come to would be best for further analysis is to drop all the rows containing the null values, which will further ease our process of doing data exploration. So we move forward, and first we check how many missing values are contained in the dataset using this function right here, and we can see all the total number of null values contained within each of the columns of data. Since then we move to drop all the null values using the drop now function right here. Using the drop now function, we drop all the rows containing null values, and using the drop duplicates function, we drop all the rows containing duplicate values. And ultimately, we are left with the dataset looking like this. And we still have an abundant number of data records left to do further analysis. So for the task 1, we were told to collect summary statistics, to visualize a summary statistics graph on current weight a year ago, and height. So for that, we move to forming the graph, which is taking in the values from the dataset, current weight a year ago, and the height. And by summary statistics, we calculate and find out all the values that are mentioned over here, which is the mean, the median, the standard deviation, the minimum value, maximum value, the values contained under 25 percentile, and the values contained under 75 percentile. The statistic summary for both the weight and the height are the same, and over here we calculate the mean, the standard deviation around the mean range also over here for both weight and height. Next, we move to plot the results that we have obtained over here into visualization using matplotlib. So we can see that we have defined the x-axis labels to be current weight a year ago, and the height. And then we move to mark the legends. Basically, the legends refer to the kind of symbols and the labels that each of the symbols of our data will represent. Meaning, if mean is a number, what kind of symbol will represent the mean value in the visualization? So we record, or we set all those parameters right here, and then we set for this visualization, we are using a dual y-axis uh, graph. So the y-axis on the left hand side is labeled weight, and the y-axis on the right hand side is labeled height, with both the y-axes containing the common x-axis value, which is current weight, weight a year ago, and height. So we move on to then plotting the summary statistics that we obtained beforehand, and we get this kind of a graph where all the values are represented as such for weight and height, both in the single graph, and all the symbols and what they represent are shown in this legend box right here. Basically, legend box means a symbol box. Now for task 2, we were told to find the correlation between the change in weight, from which is basically the difference between the current weight and the weight a year ago, with a number of other values from our data set, which is the current weight, which is and the weight a year ago, and the age. So basically we have to calculate the correlation between the change in weight with the current weight, the weight a year ago, and the age. So in order to obtain the correlation values, we used the core function, which gives us the correlation between these two parameters. And then we went on to print those values, which is shown by the print function right over here. And the result that we obtained later is shown again in another visualization, which is this time a scatter plot. So there are 3 scatter plots that we have drawn. The first scatter plot is basically the difference in weight versus the current weight, and the second scatter plot is the difference in weight versus a weight a year ago, and the third scatter plot is difference in weight versus age. And the visualization and the results that we obtain for the correlation are right here. So we can see that the correlation between weight change and current weight, and weight change and weight a year ago, and weight change and age are given over here. And these are the scatter plots for each of them. And out of all 3, we can see that the most correlated column, or the most correlated set of data that is in high correlation with weight change, is the weight a year ago. And this is all for my task. Thank you very much.